All right, so I think Friday we wrote down all the properties of rational exponents and radicals and how they're connected. And then today we're just going to crank through a bunch of problems using those properties. And so this will be like example 1B. Example 1 was me just kind of going over stuff. So A, let's do this problem. If I say 7 raised to the 1/4 times 7 raised to the 1/2, what do I do? Anybody know? What do I do with these powers here? The 1/4 and the 1/2. Well, they're both the same base of 7, so what I gotta do is I add the powers. So I'm gonna say 1/4. Let me zoom in a little bit on that. I'm going to say 1/4 plus 1/2. Now, 1/4, though, has to be converted. So what's 1/4? Actually, 1/4 is fine, but to add this up, what do? I have to have a common denominator. So I'm going to have to take the 1/2 and multiply the bottom by 2. And remember, with fractions, whatever I do on the bottom, I have to do to the top. So I end up with 1/4 plus, what's 1 times 2? 2. 2 times 2 is 4. So 1/2 is the same as 2/4, but when I add that up, it ends up becoming 3/4. And we could write that in radical form, I suppose, but for now, we're just going to leave it like that. Okay? All right, let's do another one. For this one, I've got 6 raised to the 1/2 times 4 raised to the 1/3. And then this is raised to the 1/2. Now this is an interesting one because we're raising a power to a power, but we don't have the same base. So we have to be kind of careful with that. So, like I said, think of this like the distributive property. I'm going to multiply this 2 by this 1/2, and then I'm going to multiply the 2 by the 1/3. So what we end up with in the next line is 6 raised to the 1/2 times 2, but I'm going to write it as 2/1 times 4 raised to the 1/3 times 2, right? We're multiplying it by this 2, but I'm going to write it as 2/1. On the next line, what is 1/2 of 2? It's just 6 to the 1st. This one becomes 4 to the 2/3. And so you could just leave this as 6 times 4 to the 2/3. My 2, that doesn't look like a power, does it? It's kind of almost looks like 4 2/3. So let me do a little bit better job. Okay, so let me. This is our answer for part A. This is our answer for part B. Part C. If I have the same base, 4 raised to the 5th. Oh no, these aren't the same base. And 3 raised to the same base or same power. Different bases, same powers. Raised to the negative 1/5. That's an interesting one. We could literally do this a couple of ways, but let's just go through. I'm going to take this power and multiply it by 1/5 and multiply it by, I'm multiplying the powers. I'm distributing the power of negative 1/5 through to the powers of each one of these exponents, is what I'm trying to say. And so I've got 4 raised to the 5th, but I'm going to say 5/1 times negative 1/5 times 3 raised to the 5th, or 5 over 1, times negative 1 over 5. Well, this just becomes 4 to the negative 1, and this just becomes 3 to the negative 1, right? So remember, one property we could do there is we could just say 1 over 4 to the first power times 3 to the first power. So remember that property, if we have a negative exponent, we could toss it down to the bottom of a fraction and it becomes positive. By the way, what's 4 times 3? 12. Mr. Adams isn't awake yet. Now these examples are probably a little bit harder than what's going to be on the test, but my hope and thought is that if I give you examples that are a little bit harder than what's on the test and you understand these, then when you go take the test you'll be like, oh, got it, nailed it. All right, so let's do this one. This is 5 over 5 to the 1/3. All right, and we want to reduce that. So now remember that this is really 5 to the first power, right? And we're going to subtract this 1/3 on the bottom and also from the top. But I want you to remember this, that 1 is equal to 3 over 3, isn't it? Those are the same things. Now, why would I mention that? Well, because what I'm going to do is I'm going to change this to 5 raised to the 3 over 3. Now, what that allows me to do is when I go to evaluate this, or simplify it, not evaluate, simplify, if I subtract 1/3 here, this is Mr. Adams' little shortcut, and I subtract 1/3 here, in my next line what I get is, what's 3/3 minus 1/3? 2/3. All over 5 raised to the, what's 1/3 minus 1/3? One-third minus 1/3 is 0. Okay, good. You guys aren't awake yet either. So what is 5 to the 0 power? Anything raised to the 0 power is 1. And then anything over 1 is itself. Yes?
Why would you not change the 5 to the 4 when you make that 3 over 3 above it?
Why would I not change the 5?
Because 3 to 3 is 1, so wouldn't that add to the 4 to make that 5?
No. So, all right, that's a good question. Let me try to answer it. So 5 to the 0 power equals 1. 5 to the first power equals 5. 5 to the second power equals 5 times 5, which equals 25. And then 5 to the third power equals 5 times 5 times 5, which is actually 125. And this goes on and on and on. When I have 5 over 5 to the 1/3, all the properties that we learned with integer values, like counting numbers 1, 2, 3, 4, 5. And then eventually we learned how to deal with negative 1, 2, 3, 4, 5. But really we don't use the negative powers. We just toss them down to the bottom. So those properties are basically the same. So this property here, I don't know if you guys remember this, but if I have a to the m over a to the n, then what we're supposed to do is it's really a to the m minus n. But what Mr. Adams likes to do is I said, there's a shortcut. The one shortcut, which gives you the same answer, is if I subtract n on the bottom and I subtract n on the top. And when you do that, you get a to the m. I was showing you where it comes from. A to the m minus n over a to the 0, which is just a to the m minus n. So when I'm dealing with this over here, I'm thinking to myself, okay, technically this is 5 to the first power, right? Because 5 to the first power is the same as 5. But I know that I'm going to have to subtract 1/3 on the bottom here, which means I'm going to have to subtract 1/3 up here. And I said, well, I need a common denominator to do that. So what I did is I opted to just, instead of writing, putting a 1 there, I said, well, 1 equals 3 over 3, so I'll just put 3 over 3 minus 1 over 3, because I knew I was going to do that. Does that make sense? Okay. All right. Good question. I'm glad that we took a look at that. And now I got one more problem that's a little bit lengthy. And by the way, these are the problems that you guys are going to have on the test are probably going to be a little bit easier than these. So don't panic if you're like, I'll never be able to do this. You can. It just takes practice. All right, so for this last one, this one's a fun one. I've got 42 raised to the 1/3 all over 6 raised to the 1/3 raised to the 2. So now this one is a really fun one because I see this is an interesting one. One of the properties, notice that this is raised to the 1/3 and this is raised to the 1/3. So I'm going to use one of the properties that we used before in a reverse order. I'm having like a bad hair day, I think. I'm pushing it the wrong way. Okay. Oh, that's much better. All right, so in other words, I can pull that 1/3 out and say 42 over 6 raised to the 1/3, and then all of that raised to the 2. So what's 42 divided by 6? Just 7. And 7 is raised to the 1/3, but that's also raised to the 2. So what we would do is we'd take this 2 and multiply it by 1/3. 2 over 1 times 1/3 is just 2/3, right? Because on fractions, we just multiply straight across. 2 times 1 is 2. 1 times 3 is 3. So this whole thing becomes 2/3. So it's 7 raised to the 2/3. Okay. Now, I'm going to stop here. I had to go